we want to calculate for the rectangular form, we use r cos theta plus j r sine theta, right? We use the information of r and theta, and we use this formula r cos theta plus j r sine theta to get the rectangular form. Okay, so now without the r, okay, without the r, this is the Euler formula. Okay, Euler formula. Okay, I will go straight to the one that you need to use in the calculation. Okay, normally we use this in the calculation. We look at this one. Okay, and also this one. Okay, so this square root, okay, z to the power of square root is actually power of half. Okay, z to the power of half. Okay, this one, where's the formula? Okay, he didn't state the formula here. Okay, just give this one. Okay, let me check the previous one. Power of n. If we look at this one, the formula is here, this one. Z to the power of n equals to this one. Okay, the complex number to the power of n. And when we present this rectangular form in the polar form, when we have the power of n, it will be power of n on the r. Okay, r to the power of n. And for the theta, we just multiply the n. Okay, we just multiply n. So for example, if your z is 3 and then 20 degree, then z to the power of 2, it will be 3 squared 9. And for this 20, okay, this degree, we multiply 2, we get 40. Okay, this is how we find for the power of a complex number. Okay, we put a square on the r, just like this one. When you have a power of n, your r will be power of n. And for the theta, we just multiply n. Okay, that's why when we have z to the power of half, it will be r to the power of half. And your theta, it will be times half. Okay, that's why you get this formula. When you have z to the power of half, you get this formula. Okay, r to the power of half is r. Okay, then you have theta over 2. Okay? This is how you get this formula. Actually, it's all coming from here. Okay, and if you have a power of 1 over n, okay, power of 1 over n is slightly different from the power of n. Okay, so still the r, you have power of 1 over n. Okay, and this theta, you still multiply the 1 over n, but you have this extra term. Okay, you have this extra term. You have to plus 2 pi k over n. Okay, this 2 pi k, what is k? K is this one. Okay, that means if you have, let's say z to the power of 1 over 3. N is 3 here. Okay, that means you have r to the power of 1 over 3. Okay, this is 3. And then for the angle, you have theta over 3 plus 2 pi k over 3. And your k is starting from 0 up to n minus 1. So you start from 0, 1, 2. It ends at 2 because n minus 1, your n is 3 now. Okay, n is 3. So 3 minus 1 is 2. So it will stop at 2. That means your z to the power of 1 over 3, you have 3 different values. 3 different complex number. When k equals to 0, you get 1. When k equals to 1, you combine the angle, you get the second one. When k is 2, okay, when k is 2, you combine all this, you get the third one. Okay, that means you have 3 answers for this one. If z to the power of 1 over 5, you get 5 complex numbers. Okay, 5 roots. So if you look at this simple example, let's say a is 6 plus j 8. Okay, set a, that means a to the power of half. Okay, a to the power of half. Okay, we find for the r first. Okay, this is the r. Okay, this is positive, that means first quadrant. First quadrant, this is the theta. Okay, once you get these two, this is the polar form of the complex number. Okay, then cert A is cert 10. Okay, cert is power of half. No? Okay, cert is the power of half. So 10 to the power of half. And for the angle, we need to multiply half. This angle multiplies half. Then you get this answer. So far, okay?
Okay.
Yes, madam.
Okay. If you have any questions, you can post in the chat. Okay, you can post in the chat.
Multiply or divided, madam?
Multiply,
Multiply, but that one is divided.
because this is 1 over 2. When you multiply 1 over 2, that's mean divided by 2, right?
Yes, but the answer divided by 2.
Yeah, this one. You mean this one, right?
Yes.
This one, if you look at the formula here, theta times the power is 1 over 2.
Okay,
Third,
got
right,
it.
Okay. Okay, so we get this. Next, we want a to the power 4. Okay, a to the power 4, that means r to the power 4, and then your theta, you need to times 4. Okay, we use this formula. Okay, so a is given as this. So a to the power 4, that means your 10 to the power 4, and this angle times 4. Okay, then you get this answer. Okay, so we just, okay, when you have a power of anything, okay, we just give the power to the r and we multiply the power to the angle. Okay, this is not 1 over. This is not 1 over. Okay, so we can get the answer. Okay, we get one answer. But when you have, okay, 1 over 3, 1 over 4, 1 over 5, okay, you will get this, you see 3 different answers. 1, 2, 3. Okay, because of this a to the power of 1 over 3. Okay. So this one I leave it to you. You can try on your own. Just use this formula. Okay, if you know what is the formula, okay, you can just follow the formula and you will get the given answer here. Okay, you will get the given answer here. And for the ln A, okay, just follow this one. This one seldom use ln A. Okay, we use this formula. Okay, today I want to proceed to the application. Okay, I want to proceed to the application. This one, phasors. Okay, this is what you will see in the electrical circuit 1. Okay, so this one you have learned about this. Okay, these are just repeat the operations. Okay, summation, subtraction, multiplication. Okay, we sum up the data, but the data here, they use the phi. This is called PHI, phi, a fishball, something like fishball. Okay, this is called a phi. Okay, for division, okay, this is the formula that you are going to use. For reciprocal, okay, we use this formula. Square root and complex conjugate. Okay, complex conjugate, we use this. Okay, now this is the derivation on how to get the formula. Okay, for the phasors. Okay, actually, what is a phasors? This one. Phasors, it represents the sinusoid. Okay, they use the complex numbers to represent the sinusoid. So this one I leave it to your lecturer in next semester to explain what is this all about. Okay, what I want to deliver today is how you solve the mathematical problems. Okay, so this is the formula. Now we look at how to get the formula. Okay, the phasor form. Okay, you have two types. Okay, let you know the name first. One is time domain. Another one is phasor domain. Okay, time domain and phasor domain. Okay, so we start from here. Your V, okay, this is your V. Okay, this is your sinusoid. VT sinusoid. This one. Okay, and how we relate this one to the complex number? Okay, we start from here. Okay, I use this one. Okay, I use this to the right. Okay, we start from here. We start from this one. E to the power of, okay, the simplest one, J. Okay, I use phi, I follow phi, or we use data first. Okay, we use data first. E J data is, okay, this is what you are familiar currently. Cos data plus J sine data, right? This is what you are familiar now. So if I change this into this one, the data is this one. This one you call this as omega or what? W.
Don't know.
Don't know. I don't know what you guys calling this. I call this as W first. Okay, WT plus phi. Okay, now I change this data into a new angle. Okay, I change the data into new angle. So what I get will be cos, no longer data, I use the new angle WT plus phi plus J sine WT plus phi. Okay. At this moment, we just change the data into a new angle. Okay, then when we multiply, okay, there's a VM here, right? Okay, when we multiply the VM on the left, that means we have to multiply the VM on the right as well. Okay, VM. And here we have JVM, right? We have JVM. JVM. And now we have this. Okay, then this is your sinusoid. Okay, this is your sinusoid. And your sinusoid is actually the real part. The real part, this is the real part, this is the imaginary part. So your VT is actually the only, we just take only the real part. The real part of this one, right? Correct? This is your complex number. Complex number equals to this two. And your sinusoid just now, what I show you just now, this one, your VT, this is your sinusoid. Your sinusoid is just the real part of this complex number. So we write in this form, the real part of the complex number, which is this one. So far, okay? That's why we get this. Okay?
Okay.
Okay. So now this one, I continue here. Okay, the real part, J times WT plus V. This one. This is actually JWT plus JV, right? The power. Okay, when we expand, we have J times WT, J times V. We get this. This is the power. This is exponential to this power. Okay, remember this. We have the properties of exponential function. EA plus B equals to EA times EB. Okay, EA times EB. So this one is actually EJWT times EJV. Okay? That's why your VT is the real part of this one, VM, and we change this one into this form, EJWT, EJV. Okay? Are you still with me? Are you still with me?
Yes.
Yeah.
Okay. So to get the, okay, this one, there is a name for this EJWT. EJWT, this is named as time factor. Time factor. So if you take out the time factor, what is left here? Okay, what is left here will be VM and this EJT, right? Okay, so this one, right, further, okay, from here, this is equals to RE. Okay, here I let the V, okay, I let this capital V as the VM EJV. Okay, these two, I let this two to be capital V. So this whole thing will be capital V times this EJWT. Okay, this is how we get this. Your VT is the real part of VEJWT, where your V, your capital V is actually the VMEJV. And this VMEJV, we can write in this form. Okay, you can treat this as the R, okay, something like R. And then the data now is V, so we have the angle as V. Okay?
Okay.
Okay, now you have understand this. Now we're back to the notes. Okay, so this is called, this one, this is called time domain. Okay, time domain. Okay, sinusoid in time domain. Okay, and this is phasor, okay, in phasor domain. Okay, so if you compare these two, we can obtain this from here by taking this, the coefficient of cos, and also this. Okay, the W is a constant. Okay, W is a constant. We just take this phi here. Okay, to form the phasor domain, we just take the coefficient of cos and the phi here. So we get this. Okay. There's another table here, this one. Okay, this is what you understand so far. Okay, for the cost function, this is only for cost function. Cost function, WT plus V. The phasor domain will be VM, and then the angle is phi. If this is not cos, but sine, okay, if this is sine, then we have to use the angle minus 90 degree. Okay, so these two are similar. Okay, this is just that this is VT, this is IT. Okay, one VT, one IT. You look at this notation. Okay, for cost function, you can get your phasor domain directly by taking these two. Okay, same as this. But when it is sine, okay, when this is sine, you have to use this angle minus 90 degree, okay, to get the phasor domain. Okay, so far?
Okay.
Okay. Okay. Next, this one. This one, we want to look at the differentiation of the V. Where is your V? Your V is this one. Okay, this is your V. Your V equals to this one. So when we want to differentiate V with respect to T, okay, with respect to T, okay, if you look at this, your T is here. When we differentiate exponential function, okay, I revise this with you. If you have e to the power of ft, when we want to differentiate eft, we get f prime eft. Okay, that's when you get this function back, and we differentiate this power, you get this. Now, this one, ejwt. Okay, ejwt. When we differentiate this function, we get ejwt. And then we differentiate this part, you get jw, right? Actually, that w, I think this is omega. Normally, you call this as omega. Okay, I'm not sure, but now I just call this as w. Jw, ejwt. Okay. Oh, it used this one. I'm sorry, it used this formula to differentiate. Okay, because we have this real part, we have the V. Okay, you have to show the V. Okay, it's okay. We look at this VT. Look at this VT. So when we differentiate V prime T, okay, then you get this one. Differentiate cos, you get negative sign with the same angle here. Okay, and VM, you still have VM. Then the angle inside the bracket, you differentiate with respect to T. That's why you get a W here.
Macam mana kita
Okay.
nak tahu bila time kita nak kena differentiate?
Oh, because I let you have a look at the question. The question would be something like this. Okay, you want to determine the current in a circuit described by this integral differential equation. So we have to know what is this. We have to know what is this.
Oh, okay.
That's why we need to differentiate. You have to know how to differentiate and how to integrate. Okay, so now we look at this one. So your VT is this one. When you differentiate cos, you get a negative sign with the same angle, and you still have VM in front here. And you differentiate this one with respect to T, you get W. Okay, you get this. But this is sine. Okay, this is sine. Okay, we want to change this back into cos. So how to change this into cos? We have a formula. Okay, we have a formula where negative sine, let's say A. Okay, sine A equals to cos A plus 9t. And we have another formula, which is sine A equals to cos A minus 9t. So which one to use? We look at, you have a sine function here, you have a negative here, so we choose this one. Okay. This one, you see, if I expand this, okay, I expand the cos A plus 90. Cos, that means cos A, cos B minus sine A, sine B. This one you have to know, the identity. So when we expand, this is cos A, cos B, which is 90 degree. Okay, when this is a plus, you will get a minus. Okay, for cos, it will have different sign here. Then sine A, sine B. Sine A, sine B. And we know that sine 90 degree is 1. This is 1. Cos 90 degree is 0. So 0 times cos A is 0. Okay, minus sine A times 1, you get a sine A. That's why you get negative sine A. Okay, negative sine A. Same goes to this one. When we expand this, cos A, cos B. Okay, when this is a minus, we get a plus. Sine A, sine B. B is 90 degree. 90 degree is 1. Cos 90 degree is, sine 90 degree is 1. Cos 90 degree is 0. So 0 times cos A is still 0 plus sine A times 1, you get a sine A. That's why you get a positive sine A. So whenever you have a sine function, this one, here, this one, you want to change back into cos, you use either this or this formula. It depends on your sign got minus or not. If your sign got minus, you let the data plus 90. If without the minus sign, that means A minus 90 degree. Okay, so this is how we choose the formula. So now this is minus and negative sign. So we use this formula. We want to change from sine into cos. Okay, so with the same angle here, okay, this one, same angle here. So this angle is your A. Okay, your A is this one, sine A, right? It will be equals to cos A plus 90. This one, A plus 90. So you see why we have a, and there's no more minus here. Got it?
Macam mana, Miss? Cuba ulang balik.
From
Yang nak tukar sin ke cos tu.
okay. So yang ni bila sorry. When you see this negative sine WT plus theta, okay, then we need to change into cos WT plus theta. We want to change cos WT plus theta. Okay, that means sine we want to change into cos. So you have two formula. Okay, the first one is this one. The second formula is this one. Okay, the first formula is for the sine with minus. Okay, the second formula is for the sine without a minus. Okay, so without a minus, we use A minus 90 degree. Okay, the one with minus, okay, we use plus A plus 90. Then we can change it into cos. Okay, so here, if you see the okay, so this is a sine function. We want to change into cos. Okay, sine function, we want to change into cos. We use these two formula, but because of the minus here, that's why we choose this formula, the first formula, minus sine A. We treat this as A. We treat this as A minus sine A. So these two, you still have these two things, right? So that's why you still have these two things in front of the function. Okay, no changes for WVM. But the negative sine A, we will change into cos A plus 90. That's why we have cos A plus 90. Got it?
Okay.
Okay. Then this is equals to this one. This one first. This is the real part of WVM, and then this one. This one. We can change it into this form. Too messy. Okay, this function, we can change it into the real part of this one. Okay, you have WT phi 90 degree. This means this one I have to use if you want to look at the relation, the basic one is WVM. If I use cos WT plus, okay, this is a bigger bracket, you have phi plus 90 degree. So this is the real part. Okay, this is the real part of the complex number. Okay, the real part of the complex number. So what is a complex number? That complex number will be WVM E to the power of this WT plus V plus 90 degree. Okay, with J. Okay. Right. Cos theta. Before this, you have cos theta. Cos theta is E J theta is cos theta plus J sine theta. So when your theta is changed into this, you have J theta, but now this is J theta. This is all your theta now. That means this will be changed into WT plus V plus 90, right? This is also WT plus V plus 90. And we just look at the real part. So this is cos WT plus V plus 90, this one. Got it? We have to always refer back to the basic one. Can you get the related?
Yes.
Okay. So that's why, okay, just now, I said after we take out the time domain, this is the time domain. After you take out the time domain, what is left will be your V. Okay, so your V will be these two, and VM will be your V. Okay, this means your capital V will be VM EJ phi J 90 degree. Okay, so that's why we get this JWV. Okay, JWV. Okay, this one you just need to remember. Okay, when you differentiate this lowercase of v, okay, when you differentiate sinusoid with respect to t, you get this JWV. This is capital V, phasor domain. Okay, we change it into phasor domain. When you integrate this sinusoid, you get V over JW. Okay, because you see this one, when we differentiate exponential function, we have the derivative multiplied to the exponential function. This one, derivative multiplied to the exponential function. Okay, and for the integration of EAT, okay, EAT, we get EAT over A. Okay, that's why you get over JW. Okay, these two will be used in the last part. Okay, the last part, where you need to know you have to change this one into this one into this. Okay, these are just the explanation how we get these two. Okay. Now we look at some simple examples. Okay, this one, okay, this is power of half. Polar form plus polar form. That means we have to change these two into rectangular form because this is a addition. Okay, this is addition. No matter addition or subtraction, we have to use rectangular form, plus or minus rectangular form. Okay, that's why this two, this one you change into rectangular form, which is this one. And this one you change into rectangular form, which is this. Then only we sum up these two. Okay, this one plus this, you get this. This one plus this, you get this. Then we change this back into polar form. Okay, because we want to solve for this one. Power of half. Power of half, that means this one, power of half, and this one times half. See, this one, power of half, you get this. 25.63 times 1/2, you get this. Settle for A. Okay, if you fully understand the what I teach in the class on Tuesday, this one I think you understand. You managed to understand this. Okay, because this is just top up with the power of half. Okay, for question B, polar plus rectangular form. It means we have to change this polar form into rectangular form. Okay, so we change. Where is it? Where is it? This one. This one we change into rectangular form before we plus another rectangular form. And here, this is conjugate. That's why we change the sign of this into plus before we multiply these two. Okay, so here at the top, you just sum up, you get this. And at the bottom, you need to expand. Okay, expand, simplify, then you get one complex number, this one. Okay. This one, this one, this one, and then j squared is -1, then simplify, you get this. Now, both of these two complex number, we change from rectangular form into polar form. Okay. Then this one divided by this, you get this. This one minus this, you get this. Okay, this is actually similar to what you learned on Tuesday. So far, okay?
Yeah.
Okay, madam.
Okay. If you are still do not understand, you do not get this, don't worry about that. Okay, it won't affect here. Okay, it won't affect your calculation. As long as you know this one, you change into this one, you change into this. Okay, don't worry about this. Don't let this part affect your learning now. Okay, because this is actually simple, very simple. I hope all of you manage to learn this, understand this, and know how to do it in next semester. Okay, next one, evaluate. Okay, this is exercise. Okay, this is exercise. Let's try this exercise. We try together. Okay, evaluate this. Question A. This one. Okay, question A. We have to find the multiplication. Then we minus this one. And finally, we find for the conjugate. Okay, so try to solve this. Okay, expand. Okay, then minus. Okay, this is minus. So we have to change this from polar into rectangular form. Okay, from polar into rectangular form. So this one, to get the rectangular form, 5 times cos 60. And then plus j 5 times sine 60. Okay, you have to know how to convert from polar back into rectangular and how to change from rectangular into polar, okay, in a very simple way. Okay. So this is -1. Okay. -1. So -8 minus 5, -13. This is plus j18 minus, okay, this one. Use your calculator. You will get 2.5. 2.5 plus j, okay, 5 times sine 60, you get 4.33. So when you simplify, -13 minus 2.5. These two, 18 minus 4.33. So this is conjugate. Conjugate, this means we just change the sign of the imaginary part. Okay, then we get this. Okay, any questions?
Madam, the last answer memang kena conjugate eh?
Sebab sini kan conjugate. Because of the question. Here.
Oh, okay.
It wants the conjugate. Okay, question B. B. Here. Okay, have you done question A?
Yes.
Yes.
Okay, good. Now we look at question B. Okay, complex number plus complex number. That means this should be in rectangular form. Okay, this one should be in rectangular form. So 10 plus J5 plus, okay, the rectangular form, that means 3 cos 40 plus J3 sine 40 degree. Okay. Later on, we have to do the division. So we can change this one. We can change this one into polar form first. Okay, we change into polar form. So the polar form of this, okay, you have to find for R. Okay, the R is -3. I just write 9 directly. 9 plus 16. Okay, and the angle is arctan. I'm sorry. Which quadrant is this? -3 plus J4. Which quadrant?
Second.
Oh,
Second.
2.
Second. Second, that means we have to use 180 minus the alpha. Okay, the alpha is 4/3. Arctan 4/3. Okay, and finally we sum up with this 10. Okay, plus, plus. So we have to change this into rectangular form. Okay, 10 cos 30. 10 cos 30 plus J 10 sine 30 plus J5. Okay, so simplifying. Okay, so just use your calculator. 3 times cos 40 degree plus 10. You get a 12.3. Then 3 times sine 40 degree. Use your calculator, compute the value, and then plus 5. You get a plus J6.93. Okay, here, this one. Use your calculator. You get a 126.87 degree. Okay, and here simplify using your calculator. 10 cos 30 degree is 8.66. Then 10 sine 30 plus 5, you get a plus J10. Okay, so this one you change into polar form. Okay, change into polar form. So you have you use calculator. Okay, if you are familiar enough, actually you can use your calculator to calculate directly for the R. The R is the square root of the square of this plus the square of this. Okay, then you use square root, you will get 14 12. Use the calculator to get the R directly. And since this falls in first quadrant, that means the angle will be arctan 6.93 over 12.3. You get the value directly, so that you don't have to write a lot of lines. So division, 14.12 divided by 5. 29.4 minus 126.87, you get negative 97.47. Okay, and after that, you have to plus this. Okay, to sum up these two, this one you change into the rectangular form. Okay, rectangular form. So actually, this one you can solve in one line. Okay, rectangular form means 2.824 times cos this one. Then you plus 8.66. Get the value in one shoot. And for the imaginary part, this is 2.824 times sine of this. Then you plus 10. You will get this. Any questions?
The calculation must be in polar form.
Okay. If you have to do the division or multiplication, you can choose to change into polar form because polar form is easier. But if you want to remain in rectangular form to do the division, okay, or multiplication, it doesn't matter. You will still get the same answer. We just use the simpler way. Whichever easier, we use that. Okay. Here, because the values is in decimal, okay, in decimal, so I change this into polar. If you do not want to change into polar, that means you have to multiply -3 minus J4. Okay, this one you have to multiply -3 minus J4, and at the top you have to multiply -3 minus J4 as well. Okay, then you simplify. Okay. You can use anyway. Okay, you can use anyways, as long as you feel comfortable with it.
Okay.
Okay, any more questions?
Okay, can you repeat how to get J7.2?
J7.2.
Yes.
Okay. J7.2, this is imaginary, right? Imaginary, that means R sine theta. R sine theta and then plus 10.
Oh, okay. Understand.
Because I don't want to write out so many lines. Okay, and I hope that you have know how to convert between the different forms easily. Okay, you know how to convert them efficiently. Okay, any other questions?
No.
Yang Q plus 16 tu dari mana madam datang?
Which one?
Yang first kali tu, yang 10 tambah J5, yang bawah tu. Third Q plus 16.
Q plus, not Q, this is 9. This is 9. 9 plus 16. I changed this one into polar form. So this is x squared plus y squared in the square root.
Oh.
I changed this one into polar form. Okay, you can choose to remain the here in rectangular, here also rectangular. Then you multiply the complex conjugate of this at the top and at the bottom. Then you simplify. Then only you sum up with this. Also okay. This one, since these two are in integer, actually, if you want to use rectangular form over rectangular form, I think it's still okay, not that complex, okay, because these two are integers. So if you use the rectangular form over rectangular form, it will be this one, J5 plus this one, 3 cos 40. 3 cos 40 is 2.298. 2.298. And 3 sin 40 plus J 1.928. This is -3 plus J4. And then plus, you change this one into polar. That's when you use all in polar form. This will be plus 8.66 plus J10. When you sum up, okay, when you sum up all this, you get this. So this one, 12.298 plus J 6.928 over this one, -3 plus J4, right? So these two, division, you have to multiply this -3 minus J4. So that's why here you have to multiply -3 minus J4 before you plus to this. Okay, so you have to expand, then finally you will get this.
Oh, okay.
For this question, I think this one is easier because this is integers. Okay, this one, when this is integer, it looks simpler. Okay, so this is exercise A and B. Now we're back to this. Okay, we want to see how to transform the sinusoids into phasors. Okay, now look at here. Okay, all look at the screen. Okay, this is I. Okay, lowercase of I. I equals to this 6 cos 50t minus 4t. Okay, remember the table just now. When you have lowercase of I, after you transform into phasors, you have this capital I, which is in bold. Okay, this one, the phasors will be in capital. And since this is cos, okay, this is cos function, this is what we want. So we just take the VM and also the phi to form this VM angle phi. This one, if you can't remember, I show you again the table. Okay, where is the table? This one. This one. When you have cos, we just take this, oh, not VM, IM. Okay, this is I, so IM. We just take IM and this data to form this. Okay, the coefficient of cost and this data. Okay. Here. Okay, this is your IM. This is your fee. Okay, this is in ampere. Okay, in ampere. Okay, question A, okay?
Okay.
Okay.
Okay, now we look at the B. B is V. Okay, V. But what we want, what we have is sign with negative. Okay, sign function with negative. We want to change this sign into cost. Okay, so we use this formula. Remember the formula, the first formula just now? Negative sign A is cos A plus. And this is minus, this is plus, A plus 90 degree. So now you treat this as your A. Negative sign A. You have negative sign A. 4, that's why you still have a 4 here. 4. We change the negative sign A into this one, cos A plus 90 degree. Cos A plus 90 degree. Okay, after you change this, you combine these two, you get 140 degree. So from this form, you have VM, you have phi. That's why you get VM angle phi. This is sinusoid. Your phasor will be in, phasor form will be in capital in bold. Okay, got it?
Yeah.
Good. Now we look at this exercise V. Okay, this is V. So, okay, this is very straightforward because we have cost function. So that's why we have 7. This is your VM, 7. And this is your phi. Okay, phi. Okay, B, question B, this is I. Okay, so I in phasor forms will be capital I in bold. Okay, we have negative sign. Okay, negative sign. So we use the same formula here. We want to change into cos, positive cos function. Okay, so this one, which we have a 4 here. We have a 4, and we change the negative sign A into cos sine. Sorry, we change into cos, positive cos A plus 90. Okay, cos A plus 90. So when you sum these two, you get 100. Okay, 100. VM is 4, so VM 100. Very simple, right?
Yes.
Okay, next one. Okay, you have the phasor forms. We want to find for the sinusoids. Okay, this one I revise a little bit with you first. Okay, when you have V, okay, capital V, let's say you have VM phi. So we want to change back into sinusoid. Okay, so we get a lowercase of V. So what we have the VM. Okay, we have the VM and then cos. Okay, cos function. We have the WT plus this phi. Right? From this, we change into this. So this one will give you this. Okay, so VM. Here we have cos WT plus this phi. Okay, now back to this question. This is in a rectangular form. What we need the VM and phi. So we have to change this from rectangular form into polar form first. Okay, we get this form first. So -3 plus j is second quadrant. Second quadrant, so the angle will be 180 minus arctan 4/3. And this R will be square of 9 plus 16. Okay, then we get this. In just few seconds, you get this, okay, in polar form. Okay, now with the VM and phi, VM, phi. So this is the answer. Okay, and remember, this is your I. I, after you change, you get a lowercase of I. Okay, got it?
Yes.
Okay, good. So similar to question B. Okay, B, you see this one. Sorry, this one, 8E negative J 20 degree. So this is a complex number. But we have an extra J here. Okay, that means we have complex number. J is a complex number. J times another complex number. Okay, complex number times complex number. So we want to change this, okay, this one into polar form, this one also into polar form. Okay, so for J, okay, for J, when you want to get the R, okay, this is, J is actually 0 plus J1, right? Your R will be 0 plus 1 square. That means 1. And your theta will be arctan. This is 90 degree. Okay, 90 degree. Theta arctan. Oh, sorry. J is not, J is the imaginary part. J is here. 1J. Sorry, J1. J is here, not here. So to get this, okay, this will be 90, okay, 90 degree. We don't even need to, no need arctan. We don't have to calculate because this is 90 degree. Okay, your theta is 90 degree. So that's why J is 190 degree. Okay, your J is imaginary with unit of 1. So that means it's here. The angle here, okay, the angle here, your theta is 90 degree. We don't have to calculate using the arctan. Okay, that's why J is 1 and then 90 degree. Okay, so J is 190 degree. And this 8 negative 20. 8 negative 20. This is an exponential form, right? So R is 8, theta is negative 20. So we just extract the information of R and theta, then we get the polar form. Okay, since this is multiplication, 1 times 8, we get 8. 90 plus negative 20, we get 70. Okay, so now we have already changed this into polar form. So from the polar form, we can find for the time domain. Okay, the time domain will be, this is V, right? So VM, your VM cos WT plus this angle phi. Okay, and this is in lowercase because we find for the time domain. We change the sinusoids. Okay, we change the phasors into time domain. So this is lowercase. Got it?
Yeah.
Any questions?
So for this topic, the final answer must be converted to time domain. No?
It depends on the question. If the question asks you to find the sinusoid, then your answer will be either VT or this IT. It depends. Depends on the question. Okay, so you know how to convert from time domain. Okay, this is time domain into the phasor forms. This is phasor forms. Okay, or from phasor forms, you convert into the time domain.
Oh, okay.
Yeah. Any more other questions?
If the final answer in phasor form acceptable,
Is the final answer in phasor form accepted? Is this your question?
yeah.
Okay. We have to look at the question. If the questions give you the one in time domain and it wants you to find for the phasors, then your answer will be in phasors form. If you are given in phasor forms, you want to find for the sinusoids, then your answer will be in time domain. Do you get what I mean? You see, this one, you are given phasors, you have to find for the time domains. And for this one, you are given time domain, you have to find for the phasors. Phasors domain. We are converting between two different domains. Am I answering your question?
Yes, yes. Okay.
Okay. Okay, now we look at this exercise. Well, you are given the one in phasor forms. We want to find for the sinusoid, okay, in time domain. So this one, okay, this one we have to use another formula. This one, I give you this formula. R negative R theta. Okay, if we want to change this into positive R, that means your theta must minus 180. Okay, I repeat, if you have a negative, okay, negative R, we want to change it into positive. This is the formula. We use the theta minus 180. Then you will get a positive R. Okay, so this one we have to change into positive before we proceed. Okay, because this one is your VM. Okay, we want to get VM later. Your VM must be positive. Okay, that's why we have to change this from negative into positive. Okay. So if we use this formula, okay, negative R will be changed into positive R. So what's happened to your angle? 40 minus 180, right?
Yeah.
40 minus 180, you will get negative 140. So from here, we can form the sinusoid. Okay, we form the sinusoid. So 25 is your VM. And then we have the cos WT minus 140. Got it?
Yes.
Why we can also accept this? Because remember, this is theta positive. From this direction, your theta will be negative. So negative 140 degree, that's mean somewhere here. Negative 140 is here. This is equals to 360 minus 140, right? 360 minus 140, you get 220. Okay, that's why you see this is also accepted. Negative 140 or plus 220, as long as this is positive. Okay, any questions?
So far so good.
Come again?
Okay.
I didn't get what you say.
All okay.
So far so good.
Oh, so far so good. Okay, very good. And next we look at B, question B. Okay, again, this is complex number multiplied to another complex number. So we have to solve the multiplication first. So this one, when we multiply J into this, we get J times J, you get J square, right? J square is -1. -1 times -1, you get positive, so you get positive 5. And then J times to 12, you get the plus J12. Correct?
Yes.
Yeah. This one you just expand and then you change the J square. Okay, you replace the J square by -1, then you will get this. Okay, this one we want to obtain its polar form, the polar form. So to get the R is third of 25 plus 144. And then this is in first quadrant. So this is arctan of 12/5. So what you get is 13. R is 13. And the degree is 67.38. Okay, so with the R and theta, you can form your time domain. Okay, so you have IM as 13, and then cost function, WT plus the phi. Okay?
Okay.
Okay. And then we look at the next one. I1, I2, find for their sum. Okay, we want to find for their sum. Okay, so to get the sum, remember, we can't direct sum up these two in time domain. We have to convert this time domain into phasors. Then we sum up through the rectangular form. Then only we convert back into the time domain. Okay, we can't sum up these two directly. So we have to convert into phasors forms. Okay, so this one, the phasor form is, okay, this is cos. Okay, this is cos. So for cos, it is very straightforward. So your phasor for this first one is 4, and the phi is 30. And for the second one, this is a sine function. We want to convert into cos. Remember the formula just now? If you have a positive sign, we want to convert into cos. We use A minus 90. A minus 90 degree. Because this is positive sign function. Okay, so now we change this into this form, into cos. So we have 5 cos. This one we have 5 cos. This is your A. This A needs to minus 90. Okay, A minus 90. That's why you get a minus 110. Okay, then this is your IM. This is your V. So we get the second phasor. Okay, now we want to sum up the first and second phasors, but we can't sum them up in polar form. We have to convert them into rectangular form because this is a plus. Okay, so this is cos, 4 cos 30, you get this. And then plus J, 4 sine 30. Okay, then the second part, you have 5 cos negative 110, you get negative 1.71. Okay, and then plus J, this is 5 sine negative 110. You get negative 4.698. Okay, then you simplify, you combine these two, you get this. Okay, you are given this two in time domain. So we want to get the final answer also in time domain. Okay, so from the rectangular form, to get the time domain, you have to get the polar form first. So convert this back into polar form. How to convert? Find for R. Your R is 1.754 square plus negative 2.698 square. Then you will get 3.218. And this is 1 point something, negative 2 point something. That's mean the last quadrant. Okay, this is the last quadrant. So your theta will be negative arctan 2.698 over 1.754. Then you will get this. Okay, so this is in phasor forms. We want in time domain. Okay, we want in time domain. So, okay, this is I. So your final answer will be lowercase of I. This is your IM. Cos WT. This is your phi. Got it?
Yes.
Good. Next semester, your lecturer will be very happy. Okay, next one. Exercise. Okay, try this exercise. Okay, we want V1 plus V2. Okay, this is V now. Okay, V1 plus V2. So this is given in time domain. We want to change into phasor forms. Then we can extract the information of the VM and also phi. Okay. So we change this into phasor forms first. V1. Oh, not yet, because this is negative sign. We have to change this one first. V1 in T is negative 10 sine WT minus 30 degree. Okay. So this one, is negative sign. So we have to use the formula of negative sign A equals to cos A. This is minus, so we have plus 90 degree. Okay. So 10, we have a 10. The negative sign will be changed into positive cos, where the angle will be, this is your A. So A plus 90 degree. Okay. So you get cos WT plus 60. So now you can get your first phasor, which is VM 60. So far, okay? Okay or not?
Yeah, okay, yes.
Yeah. Okay, next one, V2. V2 is cos, so we can positive cos. So we can get the V2 directly, 20 plus 45, positive 45 degree. Okay, so this is our two phasors. And we want to change into rectangular form because we want to find for the sum. Okay, so rectangular form, use the calculator, 10 cos 60. Get it directly. 10 times cos 60. So 10 times cos 60, you get 5. And then 10 times sine 60, you get a plus J 8.66. Okay, for this one, 20 cos 45. 20 cos 45, you get 14.14. And then 20 sine 45. For imaginary part, you have plus J 14.14. Okay, now you sum up these two. V1 plus V2, which is V. Okay, V is V1 plus V2. So we sum up these two, you get 19 plus J 22.8. Okay, 22.8. And what's next? What to do next?
And R.
What to do next?
Rectangular to polar.
Yes, we change from rectangular into polar form. Okay, so the polar form will be, okay, you use your calculator, you can calculate directly, okay, for this one, 19 squared, 22.8 squared, and then this is first quadrant, okay, arctan 22.8 over 19. Okay, so this one you get 29.77. And this one is 49.99. Okay. Then we can get the time domain, the sinusoid. The sinusoid is Vm. Vm cos Wt plus 49.99 degree. Any questions?
No.
Let me check whether someone dropped the question in the chat. Oh, no, no question. Okay. Next, we look at the application question. This one, have you done the exercise just now?
Yeah.
Okay, next one. Use the phasor approach. Determine the current I and circuit described by the integral differential equation. You are given this equation. Okay, so this one, you have to know what is this and what is this. Okay, just now, you have already this one. dV dt, you get JWV. Okay, integration V, you get capital V over JW. Okay, for differentiation, we have JW. Okay, multiply JW for the capital V. For integration, the capital V divided by JW. Okay, back to the question just here. For integration, we divide the capital. This is I, right? So we have the capital I divided by JW. Okay, we have an 8 here. So that's why we have 8I over JW. Just change this into this one. And for the differentiation, this is I. So we have capital I multiplied to the JW. And we have a 3 here. So that's why we have 3 here. Okay, just change it directly. Integration of I dt, we change into I over JW. The differentiation of I over dt, we change it into JWI. Okay, change into this form. Okay, and this one, I, we change into capital I. Everything in phasor forms now. Okay, everything in phasor forms now, including this one, because we want to use phasor approach. We use phasor approach. That means we change all this into phasor forms. Okay, so I, we change into capital I, and this one, this is in domain, time domain. We want to change this time domain into phasor form. So this is cos. So we can take the IM directly, IM, and this is the phi. And you are given this. What is this? You are given this 2t. What is the 2?
Alpha, omega, WW.
Yes. Okay, so we know what is this value now. Okay, next. All this, we have to simplify. Okay, we have to simplify. So how to simplify this? You replace this by 2. When this is 2, you cancel out the 2 with this, you get 4, right? So we have 4I over J. Okay, I write one more line here. So you have 4I plus 4I over J, correct? When you substitute this W by 2, you cancel out the 2 with the 8, you get 4I over J. Minus, okay, this W is 2. So 2 times 3, you get 6. Okay, you get 6. So you have J6I equals to 50, 75. Okay, so far I just substitute the value of this into this equation, the value of W, okay, 2. This. So this one, you have over J. Yeah, I write it here, your 4I over J. This is a complex number. J is a complex number. So when we want to eliminate the J, the complex number at the bottom, we have to multiply. Okay, we have to multiply the J, right? Okay, we have to multiply the conjugate. Okay, the conjugate of J is negative J. We change the sign of this imaginary part. So when you multiply these two, what do you get? Multiplies J to the negative J. What do you get?
Negative.
Negative for
Negative.
IJ. J for I.
Yes. Yeah. Here you get negative J squared, right? Up here you get negative J for I. And this is negative 1. Negative 1 times negative, you get positive 1. That's why you get only this. Okay, this is negative 1. Negative 1 times negative, you get positive 1 at the bottom. Positive 1 at the bottom. So that's why you get negative J for I. Okay, so this one, I write one more line here. Yeah. So we have 4I. 4I plus this one, right? Minus J4I minus J6I equals to 50, 75. Okay, so here we factorize the I. Factorize this one, this one, this one. Factorize, we have 4 minus J4 minus J6. And we can combine the J4 and J6 into J10. Okay, so we get this one. This one, after combined, you will get this. Okay, so to get the I, we will use this divided by this one. Okay, we want to get the I. We want to find for I. This one, move to the right, you get this. Okay, so that's why you see, you get this one. Okay.
Okay.
Okay, so this is division. We have one in the polar form. Another one we change into polar form. Okay, we use polar divided by polar. It will be easier. So this one you change into polar form, which is this one. To change into polar form, you use square root 4 square plus 10 square. Okay, then square root you get 10 over 10.77. And this is in the last quadrant. Okay, this is in the last quadrant, so the data will be negative arctan 10 over 4. Then you will get this negative 68.2. Okay, so this is division. So 50 divided by 10.77, you get this. 75 minus negative 68.2. Minus, you get a plus. That's why you get this for the phi. Okay. So this is your phasor. We want to get the answer in time domain. This question is displayed in time domain, so your answer must be in time domain. So from phasors, we want to change back into time domain. This is I, so this is IM. This is your IM cos WT is 2T now because you are given the value now. So 2T plus P. Okay, and the unit is ampere. Clear?
Yeah.
Good.
Clear, ma'am.
Any questions?
Oh.
No. If no, we look at the exercise. Okay, this one. Okay. To your dv dt. What is your dv dt? Differentiation. We change this into phasor. We change dv dt into phasor. So we have V in capital. Okay, we have V in capital. This is differentiation. So we have J, W. Okay, plus V, plus 5V, okay, capital V, plus 10. Integration. So we have capital V over J, W. Then this is cost function. We don't have to change anything. So we proceed to get the VM. VM, and the phi is negative 30. Okay, negative 30. And we know that the W is 5. Okay. Okay, here we settle this one first. You have W as 5. You substitute this W by 5. 5, 2, you get 10. J 10 plus 5V. When this W is 5, cancel out the 5 with this 10, you get 2. Okay, 2V over J. Then this one, we multiply. Okay, we want to get rid the complex number at the bottom. So we times the complex conjugate times negative J. So we have J10V plus 5V. Okay, this one, J times J, you get J squared, which is negative 1. Negative 1 times negative, you get positive 1. Okay, so at the bottom, you get positive 1. So here you get minus J 2V. Then factorize. Factorize the V. You have 5. And this 2, 10 minus 2, you get a plus J8. Then we want to get the V. So we move the 5 plus J8 to the right. And this is division. So we will change the denominator into polar form. To get the polar form, use your calculator, compute directly. to get the R, you need to use square root of 25 plus 64. Then you get a 9.43. Okay, then this falls in first quadrant, so you use arctan. Arctan 8/5. So you get a 58 degree. So when you divide, when you do the division, 50 divided by 9.43, you get a 5.3. Negative 30 minus 58, you get negative 88. Okay, so this is your V, but we need to change this phasor into that time domain. Okay, into time domain. So VT, lowercase of v, VT is, your VM is 5.3, cos W is 5, minus 88. Any questions?
The letter V need to write or not
The letter V.
for the
What is
final answer?
Oh,
Final-
okay. The unit.
Voltage.
Yes, voltage. Okay, that is unit. Any other questions?
No.
No.
No. Okay, so if there is no more questions, that means we have done this complex numbers.
Miss, snap the calculation. Can?
Not the calculation. You mean you want me to snap the calculation?
Yeah,
Or what?
yeah. Yes.
Snap and
Okay, thank you.
okay, you want to snap. Okay. So suppose we need to use 2 weeks time. We have 2 weeks time for these complex numbers. Okay, but next week I don't plan to carry on with complex number with the OCW slides, since it is not covered under any of your assessment, and it is not so far. I think it is not used in any of your engineering subjects. Okay, for the topics, the lockers, all this. So I will just skip that part. So next week, I will go into next chapter. Okay, we move into next chapter. Interpolation. Okay, interpolation. But next week, Monday is a holiday. Okay, Monday is a holiday, so there is no class for section 1. So for section 2, I plan to continue the class on Thursday. Okay,
Monday.
follow section 1. Follow section 1, no class on Monday. So Tuesday, I also give you a rest. Okay, we don't proceed to interpolation on Tuesday. Okay, I will start the interpolation, the next chapter, on Thursday. Okay, but since we don't proceed to the next chapter in next Tuesday, so if you have, I welcome any kinds of questions. If you want to do any revision on the previous chapter, okay, I will welcome you to join the teams. Okay, I will still run the class on Tuesday, but I won't proceed to the next chapter. I will just run as revision class for any of the topics. Okay, since the first chapter until now, this one, complex numbers. Okay, so you can prepare your questions. Okay, and I will revise, okay, on next Tuesday with you during the class time. Next Tuesday is 8:30, right? We start the class at 8:30 in the morning. Okay, so if you want to, I will go through the feedback. So I hope you guys can fill up the feedback if you haven't do so. I will go through the feedback and I will choose certain topics. Okay. And if you have questions, okay, please, okay, bring along your questions. Okay, no matter the question is in the form of tutorial or the question, specific question on the topics where you do not understand. Okay, I try to clear your doubt, okay, in the during that time. Okay. Any questions?
No, ma'am.
How about attendance, madam?
Attendance, I will extract from Teams.
Okay.
That means who joined the Teams today, I will take their attendance. Okay, I take the attendance based on the attendance captured by Teams.
Okay, Doctor.
Any other questions?
No, Doctor.
Madam,
Yes.
Okay.
for next week Tuesday, can we have online class?
First day.
Yeah.
Why you want to stay in hometown for the whole week?
Yes, madam, because I think I cannot be here by next Thursday.
What about others? You will be back for other classes, right?
No, madam.
No, I mean other students.
Oh,
No, ma'am, because there are no classes on Thursday and Friday for us.
No class on next Tuesday, Thursday and Friday.
static.
So you guys stay in hometown, all of you? Is it all of you or just some of you? I want to know. If just some of you,
Some only.
Some.
if just some of you, that means I will proceed with the face-to-face class. But for those who stay in, still stay at hometown, you just join online class.
Okay, madam, can.
Okay, but I want to know how many of you will come to the physical class. I think I will run a poll in the WhatsApp later.
All right.
Okay, if the number of students is quite some, then I will proceed to the physical class, because interpolation, if possible, I want to do a face-to-face class. But if most of you, if majority of you are not attending the physical class, then I will just run the online class. Okay, so I will post the poll later in the WhatsApp group, so please respond, okay?
Okay, madam, sure.
Okay, any
Okay,
other
I
questions?
know.
When is the midterm test? When is the midterm test?
Midterm test. So far, what I received, the information is on December, 14th of December.
14
8:30
December.
PM.
Okay. Okay.
So
But I'm not sure whether
our midterm break.
I'm not sure whether is there any changes because this date is already changed many times. Not yet
Oh.
confirmed. That's why I didn't announce in the group.
Okay. Okay. Okay.
Doctor.
So the midterm break will be after the midterm test, is it, teacher?
Yes,
Okay.
should be lah.
Doctor, which topic will come out for the midterms?
Okay, topics. I'm still waiting the info from the coordinator because I haven't received the confirmed date and also the topics. But once I receive it, I will let you guys know. Okay, but what I know is the if not mistaken, the bisection is included in the midterm, if not mistaken. Bisection method. Okay, I will let you know in the group once I get the information. Any other questions?
Oh,
So far okay.
Okay. Okay, so later I run the poll in the group. Okay, then I will decide whether we will have fully online class or hybrid class on
Okay, that's
next Thursday. Okay, we are talking about Thursday class, right?
Yes,
Yeah.
madam.
Next Tuesdays is still online class, online revision class. Okay, online revision class. I try to get some information from the coordinator, see which topic is coming up. Then we do some revision, okay?
Okay.
Okay, so I will see you on next Tuesday online.
Okay, doctor.
And happy Diwali to all students who celebrating it, and happy holiday to the rest.
Thank you, madam.
Okay, see you guys.
Thank you, madam.
Thank you, madam.
Okay.
Happy Deepavali.
Okay.
Bye, ma'am.